At our second half of application problems, we're going to model and solve problems with right triangles. Last time we just had formulas that were already with the relationships, and we could just plug those equations into the calculator and solve them. This time it's a word problem where we're going to have to draw some pictures, us figure out what's on with the problem. One of the most common problems here is in number 40 with a surveyor. Use right triangle trigonometry a lot. So the context of the problem, the lake, doesn't so much matter as we have a triangle that's going to look like this, where the surveyor is standing over here on this side of the lake. He's measured a distance to another point over here that I'm going to call C because this is a right angle. This is the point that he's in over here on the other side of the lake where he wants to measure this of the lake. He's at point B here. And he's measured distance E to feet. And he's measured this angle here as 65 degrees with a instrument called a transit. So he's also measured that A and C are directly across each other in this example. C piling, the pier, and we want to find the distance there. So we have an opposite side and an adjacent side. So we're going to use the tangent function. The tangent of 65 degrees is equal to x over 100. So 100 tangent of 65 degrees is equal to x. I'm still in degree mode from my previous examples, so I'm going to type in 100 tangent of 65, and we want to round to the nearest foot. This is approximately 214 feet. Now the context of the problem changes. Instead of a horizontal two-dimensional situation, we've flipped the triangle up and we're talking about a radio transmission tower this time, but really the same picture where there's a person standing at the away from the base here at point B, and we know that a radio transmission tower is 130 feet tall. This wire going from A to B is called a guy wire. It's used for support. So we want to find how long that should be. If it is attached 10 feet from the top, so we have a look at extra here that this is 10 feet, so there's 220 feet down here, 10 feet up here, and want to make an angle of 32 degrees with the ground. So the entire tower is 230 feet tall. We need to take 10 feet away to get to the attachment point, so it's only going to be 220 feet above the ground. And we need a relationship that has opposite and hypotenuse. So sine of 32 degrees is equal to 220 over x. So x is equal to 220 divided by sine of 32 degrees. Let's type the calculator. 220 divided by sine of 32. It's going to be, we want nearest tenth of a foot here, so 415.2 feet. this. A similar picture again, a building that is 270 feet tall, casts a shadow that is 100 feet. Person looks down from the top of the building, like so. This angle, look down. Is the measure of between the end of the shadow and the vertical side of the building. Well, I'm going to angle here with them looking, and this angle here are the same. So if I was standing on top of the building and looking down, it's called an angle of depression, or in physics we sometimes call it an angle of declination, because you're declining, right? This angle here is called an angle of elevation, and sometimes we'll call that an angle of ascension. See if I can spell that right. Ascension. Ascent is with a T, but when we switch it, I think it switches to an S or a C. Maybe it's Z. Anyway, ascension. You'll recognize it when you see it in your physics class. So we're either looking up to the object or looking down from the object, but because of geometry, with these two lines being parallel to each other and this hypotenuse being a transversal, the alternating interior angles are going to be congruent. Whether I'm looking down from the top, up from the bottom, the angle measurement is going to be the same. That's just right here. So assume that the person's eyes are level with the top of the building, right? So we're going to say that tan of theta is equal to 70 over 100, like so. And then we have not done anything with inverse functions to my knowledge, but we would solve this by saying theta is equal to arctangent of 270 divided by 100. So let's do with our calculator. And we have to use a inverse trig function for an angle like that. So the nearest tenth of a degree, to the nearest whole degree, this is about 70 degrees. John, whose lineup is 6 feet above horizontal, is trying to estimate the height of a tall oak tree. So his eyes, he's 6 feet. Here's the horizontal. He's looking up from where he's at to estimate the height of this tree over here. He measures the elevation from where he's standing to be 35 degrees. And if he walks 30 feet closer to the tree, so he's now going to stand, here's position 1 where he's going to stand, position 2 over here where he's going to stand. If he measures from here, it is now increased by 20 degrees, so it's 47 degrees here to look at the top of the height of the tree. So this side, this height of the tree has not changed. We're going to use tangent, and we're going to say that tangent of 35 degrees is equal to, and I'm going to call this horizontal side here X. I'm going to call this vertical side here Y. Say that X tan of 35 degrees is equal to Y. I'm going to set up another equation over here that says tan of 47 degrees is equal to, and that's the same Y, but we have lost 10 on the axis. So 30 feet, excuse me, X minus 30. So he's 30 feet closer. So X minus 30 times 10, 47 is equal to Y. Well, Y and Y are the same thing. So this is X 10 of 35 degrees is equal to X minus 30 tan of 47 degrees. So let's go ahead and get our x's together. Use the distributive property here. And x tan, let's bring it over to make it positive. 30 tan 47 is equal to x tan 47 minus x tan 30. 5. Tan 47 is x times tan 47 minus tan 35. And we're going to divide now. That x is equal to 30 tan 47 divided by tan 47 minus tan 35. And that's approximately be see 30 tan 47 divided by tan 47 minus tan 35. Now this is only helping me find y, which is the height above John's eye level. So we want to estimate the height of the tree rounded to the nearest whole number. So this 86 roughly, but I need to add 6 feet to that. So the tree is approximately 92 feet. All right, I'm going to come back and do a few more problems in my next video, but I'm going to there. So see you for the next video.